Welcome back. Today we are going through lesson 13.6, which is all about the fundamental trigonometric identities. So we call these the trig identities for short, and we're going to go through them today. There's a few different categories of them that we're going to use to kind of help us. So the first ones, well, first of all, a trigonometric identity is a trigonometric equation that's true for all values of the variable for which both sides of the equation are defined. So let's look at a few examples to kind of help us. So these first ones should look familiar. These are going to be the reciprocal identities, which we've talked about before. So we know that cosecant of theta is the same or is equal to 1 over sine of theta. So the reciprocal is where we flip that fraction. So 1 over sine theta and cosecant theta is a trig identity because both sides of the equation are true for all values of the variable on both sides of the equation where it's defined. So you can see a couple others there. So we have secant theta, which is 1 over cosine theta, and tangent theta, which is 1 over cotangent theta. And then the same thing is true in reverse. So sine is the same as 1 over cosecant. Cosine is the same as 1 over secant theta. And cotangent is the same as 1 over tangent theta. A couple other identities that we need to remember is that tangent of theta is the same as sine over cosine of theta. And then cotangent is the opposite of that. So the cotangent of theta is the same as cosine theta over sine theta. So those are 8 trig functions or trig identities that we've kind of worked with before and talked about before, and they are true for both sides of the equation where the variable is defined, and so they count as trig identities. What we're going to do now is we are going to develop some other trig identities. So one group of those is called the Pythagorean identities. So we're going to kind of walk through some steps here to help us answer this and figure out those Pythagorean identities. So first thing we're going to remember is the Pythagorean theorem. So for the triangle to the right here, we see that C is the hypotenuse. So the Pythagorean theorem would be a squared plus b squared equals c squared. So that part we should know from geometry. What we're going to do now is start to kind of change that equation around or move the equation around to identify an identity. So first we're going to divide each side of the Pythagorean theorem equation that we just wrote by c squared. So I'm going to take that a squared plus b squared equals c squared, and I am going to divide both sides by the c squared. What that allows me to do is it allows me to get the right side of the equation equal to 1. So it would look like this. All right, so now we have an equation that equals 1. We're going to write equations for the sine and cosine theta. So with that, we know that sine of theta in this triangle up here, so remember here's your theta, and in that triangle with theta being where it is, B is the opposite side, A is the adjacent side, and C is the hypotenuse side. So the sine of theta in this case is opposite over hypotenuse, which is B over C. The cosine of theta for that triangle is the adjacent over the hypotenuse. So those are the two equations for that. All right, now we're going to use that to help us finish this off here. So the equations that we just came up with for sine and cosine, we are going to square each side. So we're manipulating those equations to start to figure some things out. So we're going to use that sine theta is b over c, and we're going to use that cosine theta is a over c. And like it says in the directions, we're going to square both sides of those equations. And when we do that, we get sine squared. So when we square that, we write the squared in between the trig function and the theta equals b squared over c squared. And then we've got cosine squared theta is a squared over c squared. So using that information, we're going to rewrite the equation from problem 2. So if you remember from before, the equations that we came up with in number 2 was a squared over c squared plus b squared over c squared equals 1. Well, now we can replace that. Let me write it here first. So we had a squared over c squared plus b squared over c squared equals 1. Well, now we know that from up above that a squared plus c squared right here is the same as cosine squared. And we know that b squared plus c squared is the same as sine squared theta. So our identity that we find that's most important here, our Pythagorean identity, is that cosine squared plus sine squared equals 1. So that is our Pythagorean identity that we are going to use when dealing with these trig functions. So what we're going to do next is we are just going to kind of confirm that identity that we just came up with to make sure that it truly does do what it says it's going to do. So when we take cosine squared plus sine squared of a certain angle, is it really going to give us a value of 1? So we're going to test it for a point in each quadrant just to kind of see how it works out and if it's truly a true identity. So if we think about pi over 4, the sine of pi over 4 is the square root of 2 over 2. So when I square that, I would get 2 over 4, which is 1/2. The cosine of pi over 4 would be also the square root of 2 over 2. So when I square that, because it's cosine squared, I again get 2 over 4, which is 1/2. So when I do sine squared plus cosine squared, I can see that the identity holds true. It equals 1. Now let's try it for 5 pi over 6. So in the second quadrant, we have 5 pi over 6. So the sine of 5 pi over 6 on my unit circle is 1/2. And if I square that, I get 1/4. The cosine of 5 pi over 6 is negative square root of 3 over 2. So squaring that, a negative times a negative gives me a positive, and then I would have 3 in the numerator and 4 in the denominator. So when I take sine squared plus cosine squared for pi over 6, I also get 1. So it still holds true for that second quadrant value. In the third quadrant, we're going to test 4 pi over 3. So we're testing a variety of points here to make sure it holds true for all of them. So if I use my unit circle, the sine of 4 pi over 3 is negative square root of 3 over 2. So squaring that, I again get 3/4. And the cosine of 4 pi over 3 on my unit circle is negative 1/2. So squaring that, I get positive 1/4. And again, when I combine the sine squared plus the cosine squared, I still get 1. All right, and then in quadrant 4, we have 11 pi over 6. So sine of 11 pi over 6 is 1/2. So squaring that, I get 1/4. And the cosine of 11 pi over 6 is square root of 3 over 2. So squaring that, I get 3 over 4. And again, when I add sine squared plus cosine squared, it equals 1. So we've shown that in every quadrant, the sine squared theta plus the cosine squared theta is still equal to 1 when we add them together. All right, so that helps confirm it. It doesn't prove it because we haven't proved it for every value, but it does help confirm it that indeed cosine squared plus sine squared theta, or cosine squared plus sine squared theta is always equal to 1, is a true identity for our unit circle. All right, we're going to continue to build on that a little bit here. So what we're going to do now is we're going to take what we already had, that key trig identity, and we're going to build another one based on it. So we are going to take that trig identity that we had, cosine squared theta plus sine squared theta, equals 1. And we're going to manipulate it a little bit to help us here. So to do here is divide each side of that Pythagorean identity by cosine squared. And then we're going to simplify it. So cosine squared, dividing on each side. We're going to use some things that we already know, and then we're going to use some identities that we talked about earlier. So to start with, cosine squared divided by cosine squared. Anything divided by itself is 1. So that part simplifies to 1. We know from up above when we were talking about our original identities, sine squared theta over cosine squared theta, that is tangent squared of theta. So that's the definition of tangent. So we can replace that there. And then finally, we know from our reciprocal identities in the beginning that 1 over cosine squared theta, that is secant squared theta. So we have simplified that. Now it says to divide that same identity that we were working with before, but this time divide it by sine squared. So going back to that original one from step 5 up above, we are going to divide it this time by sine squared theta everywhere. Let's see how that changes things. So now starting from left to right, we have that cosine squared over sine squared. Again, from our identities up above, we know that that is cotangent squared of theta. We know that sine squared theta divided by itself is 1. And we know that 1 over sine squared theta is cosecant of theta. All right, so we have now created 3 other key identities that we want to use here. So we have the one up here from above, and then we've created 2 more here that we want to remember. So on the next page, we are going to summarize and put those all together. So here's what we're looking at. Oops. All right, here are the 3 trig identities that we just had. We're going to put them all in one place so we have them. So the first one we had, I'm just rewriting it kind of in a different order, but sine squared theta plus cosine squared theta equals 1. The second one we came up with, or we showed, was 1 plus the tangent squared of theta is the same as secant squared theta. And then the last one we just derived by dividing by sine was 1 plus the cotangent squared of theta equals the cosecant squared of theta. So those are 3 more identities, as well as the ones we already talked about, that can help us to simplify problems. So let's look at a few examples of that. So this first one says, given that sine theta is 3/5 and that we're between 0 and pi over 2 in the unit circle, find the values of the other 5 trig functions. So what we know right now using our trig identities, let's go with the Pythagorean identity that we started with here. So sine squared theta plus cosine squared theta. So I'm using that one because I was given this sign here, equals 1. So that trig identity is true. We've shown that now. So what we're going to do is we're going to replace what we know here to solve for the other identities I don't know, or not the identities, the other trig functions I don't know. So we know sine theta, we need to find cosine, tangent, cosecant, cotangent, and secant. So I know that the sine of theta is 3/5 from the problem. So I can plug that in there by squaring it. And then I'm going to use that to find what cosine is, since I know this identity is true. So simplifying that, I'm going to say that cosine squared of theta is 1 minus, and then I'm going to go ahead and square the 3/5, so 9/25. So I've moved the 3/5 squared to the other side. When I simplify that, I get that cosine squared theta is 16/25. And so when I square root that, I get that cosine of theta is plus and minus 4/5. I'm going to write that over there a little bit. All right, so we've gotten the cosine. Now we need to find tangent So I know from my tangent identity that tangent is sine of theta over cosine of theta. So remember that from that first page that we talked about. Now I know from the problem that sine is 3/5 and cosine is 4/5. So when I divide those, I get 3/4. So tangent is 3/4. We've got cosine down here, and then we know sine from above. So I've got the three regular trig functions. Now we're going to find those reciprocal functions. So for cosecant, I'm just going to change colors so we can keep track here. For cosecant, using my reciprocal identities, I know that's 1 over sine theta. So I've got 1 over 3/5 because I know that sine is 3/5. And when I simplify that, I get 5/3 for cosecant. We're going to use something similar for secant of theta. So I know that secant is 1 over cosine from those reciprocal identities. So that would be 1 over 4/5, which of course would simplify to 5/4. And then lastly, I've got cotangent of theta. And we know that that from the cotangent identity is cosecant over, or cosine, sorry, cosine over sine. So when I do that, I have 4/5 over 3/5. And when I simplify that, I have, whoops, 4. When I simplify that, I get 4 over 3. So those are using the identities to find our 6 trig functions. We're also going to use the trig identities to simplify. So when we simplify, we're looking to replace things in the expression in order to simplify it a little bit. So in this example, I've got cosine of x times secant of x, and I'm dividing by cotangent of x. So the first thing I always try and look for is some of those reciprocal identities. So I know in this case that if I have cosine of x, instead of secant of x, I can simplify that or change it using an identity to 1 over cosine of x. So I try and think about how I can rewrite things in the same trig function. So getting these both to cosine kind of helps me. And then let's leave cotangent alone for right now. So on the top, in the numerator of that fraction, cosine of x times 1 over cosine of x, that's just 1. And then I have cotangent of x in the denominator still. And from my reciprocal identities, I know that 1 over cotangent of x is tangent of x. So we are using the identities to simplify a more complicated trig expression into a much simpler one. All right, let's do the same thing for b here. So I've got cosine of x plus sine x times tangent x. So again, cosine and sine aren't too bad, but I'm going to change that tangent. So I'm going to rewrite this as cosine of x plus sine of x. And I'm going to change the tangent to sine of x over cosine of x. Again, trying to get everything kind of into common things. I'm going to zoom in a little bit here just to give myself a little more space to kind of write things here. All right, so when we simplify that, we get cosine of x and sine of x times sine of x over cosine x would give me sine squared of x over cosine x. So I've simplified a little bit there to kind of change that, but we need to continue. So I've got 2 things being added, so I'd like to be able to add them together. I am going to get that common denominator by multiplying this left one by cosine of x over cosine of x. So not changing its value, I'm just multiplying by 1, but giving it that common denominator. So this top part here would be cosine squared of x over cosine x. And then I'm adding to it sine squared x over cosine of x. And what I've created here in the numerator, since I have a common denominator, is something I can simplify. So we know from our Pythagorean identities that cosine squared plus sine squared is 1. So now I have 1 over cosine x. And we know from our reciprocal identities on the first page that that is equal to secant of x. So we've taken a more complicated trig expression and reduced it down to a single trig function. All right, the last thing we're going to use trig identities for, let me zoom back out so we can see it all, is to verify or show that this statement is true. So we are going to use our trig identities to verify that statement. Okay. So I'm going to zoom in again just because we have a lot to kind of squish in here, so giving myself a little more space. All right. So on the left side, I've got tangent x plus cosine of x, and I am trying to prove or show that sine of x times secant x plus cotangent x are the same, right? We're trying to show that both sides of the expression are equal to each other. So I am going to simplify this right-hand side, and I'm going to try and show or verify that it actually equals tangent x plus cosine x. So I am trying to simplify that right side to make it equal tangent x cosine x. So what I see here is a monomial being multiplied into a binomial. So I'm going to distribute this, and I am going to get the sine of x secant x plus sine of x times cotangent of x. So I've distributed there. And now, again, I'm looking to simplify things so that they are in the same trig function. So for sine of x, I know that I can leave that and I can change the secant of x to 1 over the cosine of x. So when I simplify that, I get sine of x over cosine x, and I know that is tangent x. So I've kind of confirmed this first part. Oh yeah, it does have a tangent x in it. Now I'm going to try and simplify to make the second part the cosine of x. So let's continue on with the rest of this. So again, I'm going to leave sine of x alone, and I'm going to rewrite cotangent as cosine of x over sine of x. So now they're kind of talking the same language. When I do that, the sine of x divided by the sine of x becomes 1, so I don't need to write that, and I'm left with just cosine x. So now, if I carry that through, I have confirmed that the right side is also equivalent to tangent x plus cosine x, and so I have verified that. So these are some ways that you can use trig identities to simplify and show equivalence. We'll see you next time.